Hello everyone, this is Sam. Welcome to the fourth video of my YouTube channel, Data Science with Sam. In today's video, I'm going to talk about linear regression, a very widely popular technique that we use to build machine learning applications in today's technology world. There are a lot of industries, starting from healthcare to finance or automobile industry, they use linear regression technique to build machine learning real-life applications. The term regression was first coined by Francis Galton in the 19th century to describe a biological phenomenon, which is nothing but to describe the height of tall descendant of ancestors, which usually regress down to the normal average. The general form of linear regression is based upon the linear algebra that we learned in the mathematics class of our elementary school. You remember the formula? Yeah, it's y equal to mx plus b. But y is nothing but the dependent variable that we're trying to predict here. The x is the variable which we use to predict y. M is the slope and b is the interceptor. When you transform that linear algebra to linear regression, there is one more variable we usually talk about, which you call a regression residual. But in this video, I'm not going to talk about that. So keep aside residual part for now. So what is slope? Slope is interpreted in algebra as rise over run. For example, if the slope value is 2, that means if you move along the x-axis and the value of the x variable gets increased by 1, then the value of the y variable should get increased by 2. So the slope value can be obtained by dividing the difference of the y coordinates of 2 points by the difference of the x coordinates of the same 2 points. Check out this formula. Now what is intercept? The y-intercept is nothing but where the regression line crosses the y-axis. It's where the x becomes 0. That's where we actually have the intercepted point for a regression line. Linear regression can be categorized into two different types based on the number of independent variables we are passing in as inputs to the model. Like for single linear regression, we pass only one variable to predict y. But for multiple linear regression, we pass multiple independent variables to predict y. For example, a company can use only the sales value to predict the profit margin. In that case, that should be an ideal example of single linear regression. But if the same company would combine their sales margin and operation cost to predict the profit margin, then that will be considered as a multiple linear regression. Here is a very basic example of performing single linear regression using Excel. First step, create x and y variables and assign random values to it. Second step, use Excel's inbuilt formula, slope and intercept, to measure those two parameter values. Third step, pass those two parameter values over here. Fourth step, create regression line using Excel's line chart feature. And the fifth step is use the add trend line option to see how the trend line shows on the regression plot, and also display the equation which corresponds to that regression equation all for today. Shown over here. If you like my video, please don't forget to subscribe to my YouTube channel, Data Science with Sam, and also share it with your friends who want to learn data science. In my next video, I'm going to talk about how to perform linear regression using R programming language. So stay tuned for that. Also look down in the video caption to find out more materials related to linear regression. So stay tuned. Till then, goodbye.